All right, in this video, we're going to go over section 4.1, which is solving linear equations by graphing, or linear systems by graphing. Now, we've learned from uh, our support work, you have ax plus by equals c. We know when we graph that, that's a straight line. And if we have two of these equations, it's known as a system of equations. Since they're linear, we can call it a system of linear equations. What we want to look at, we want to find a solution. A solution is an ordered pair that meets the criteria of both equations. So let's look at an example. Suppose I have the equation x plus y equals 7 and x minus y equals -1. This is a system of linear equations. They're both in the form ax plus by equals c. Now, in this case, both a's and b's are equal to 1, so we don't write it out, but they're there. Now, let's find something that meets both solutions. But here's what I want to do. I'm just going to randomly pick, the ordered pair 3, 4. Let's see, is this a solution to both of these? We put 3 in for x. Let's look at x plus y equals 7. Put 3 in for x and 4 in for y. 3 plus 4 equals 7. So it meets that criteria. Now let's look at another one, our second one. X minus y equals -1. Put 3 in for x, 4 in for y. 3 minus 4 equals -1. So this is a solution. That is a solution to that system of equations. One more. How about let's look at x plus 2y equals -2 and x minus 2y equals 6. So this will be our system of equations. And we want to look at the points 4, -1, and -4, 3. Let's go ahead and let's plug them in. X plus 2y equals -2. So x is 4 plus 2 times -1 equals -2. All right, is that all right? Oh, I meant to say equals 2. Sorry. Positive 2, not -2. Sorry about that. Hope you're not writing it in pen. 4 plus 2 times the -1 equals 2. So 4, 2 times the -1 is -2 equals 2. Is that a true statement? Yes. So it fits for the first one. Now let's try it for the second one. 4 minus 2 times -1 equals 6. So 4, -2 times -1 is a +2 equals 6. So the point 4, -1 fits both equations. So this is a solution. Now let's try the point -4, 3. -4, 3. Well, let's do the top one. X plus 2y equals 2. Plug in -4 for x, so -4 plus 2 times 3 equals 2. -4 plus 2 times 3 is 6 equals 2. -4 plus 6 equals 2, so it works for the first one. Now let's try x minus 2y equals 6. Negative 4 minus 2 times 3 equals 6. Negative 4 minus 2 times 3 is 6 equals 6. Is this a true statement? Does negative 4 minus 6 equal 6? No, it does not. So this is not a solution. That is not a solution. All right. Now let's talk about how we can solve these graphically. Let's talk about doing this graphically. First thing we want to do, we want to make a coordinate plane. We talked about in our support material. I'm going to make a coordinate plane. Remember, you have your x-axis and your y-axis. I don't think I mentioned it in the other video, but your point 0, 0 is known as your point of origin. So if you want to remember that, it's the point of origin. Let's take a look at how about x plus 2y equals 2 and x minus 2y equals 6. Well, for starters, let's find the intercepts of each equation. Let's find the intercepts of each equation. X plus 2y equals 2. And draw this out. Now, for the y-intercept, x is equal to 0. So we're left with 2y equals 2, so y is equal to 1. For the x-intercept, y is equal to 0. So you're left with x equals 2, so 2. So we know we can plot the points 0, 1, and 2, 0. We have our linear equation. Now let's do the same thing for our second equation. Again, for our y-intercept, x is equal to 0. We have negative 2y equals 6. That means y is equal to negative 3. And then for our, excuse me, for our x-intercept, y is equal to 0. So you're left with x equals 6. So we have the point 0, negative 3, and the point 6, 0. All right, I didn't draw the best line there was. But you can see there is a point right here where they intersect. That is the solution of the equation, of the system of equations. Okay, now I'm not going to solve this one. Now we're going to go ahead and try one, and we're going to solve for the point of intersection. Sounds like fun, doesn't it? All right, let's try. For starters, I'll have my coordinate plane. I have 2x plus 3y equals 6. And then 2x plus 4 equals negative 2. Now, if you want, go ahead and pause the video and solve for the two intercepts for each equation. And once you have it, come back and pick up the video. So pause it, solve, and then come back. All right, welcome back. Let's solve for our intercepts here. For the y-intercept, x equals 0. You get 3y equals 6, so y is 2. Then take that out. X is equal to 3. 0, 0 if x equals 0, 4 equals -2, so you're at -1/2. And then, did I mean to say 4y? Probably. Oh, dang it. I screwed this whole problem up because I can't read my own handwriting. I'm sorry, guys. Let me start this over. Well, only the second part. I don't know why I said 2x plus 4. I'm going to say 2x plus y. I can't read my own handwriting. Sorry about that, guys. You're probably confused on how to solve for the intercept, aren't you? That makes a ton of sense. Wrote down the problem on a sticky note. I thought my y was a 4. I don't know what I was thinking. My apologies. Anyway, let's try this one. So, okay, got when y is equal to 0, x equals 1. When, oh, I did that backwards. Man, now I'm really off. I'm sorry, guys. When x is equal to 0, y is equal to -2. When y is equal to 0, x is 1. Yeah, I did do that right. I'm sorry. I'm just messing up all over the place right now. Anyway, now we can plot our points. We can go 0, 2. We can go 3, 0. Draw the line. Now for the second one, we can go 0, -2. Then we can go 1, 0. Now, if we look at this point of intersection, we know it's in quadrant 1. So we know that both the x and the y are going to be positive. Right? I did not draw this graph very well, did I? My apologies. But when you do this on your computer, you'll have a graph given to you. Whatever the point of that intersection is, that's what you want to use. When you see it on your computer, you'll be able to highlight it. If you do this on graph paper, you'll be able to highlight it. You'll be able to work out pretty snug for you. If you have any questions, again, don't hesitate to email me. Now, we did both of these in the AX plus BY equals C format. What happens if we're given slope-intercept form? That's a great question. Let's talk about that. What if I write this one down right off the bat? Y equals -3x plus 2. And I give you y equals 5x minus 6. This is our system. Well, right off the bat, we know what our y-intercept is. Remember, our b value is our y-intercept. We have our y equals mx plus b. So the top one, our b value is 2, so 0.02. And we know the slope is -3. So that means we go down 3 over 1. So that's going to give us point -1, 1. Right? I'm sorry, 1, -1. Give us a point 1, -1. We can draw a line like that. Now let's look at the other one. We know the intercept, the y-intercept is 0, -6, and the slope is +5. So we go up 5 over 1. Well, look at that. They both hit the point 1, -1. So 1, -1 is your solution. It's growing up. Too bad. All right, now I want to talk about one final topic. So far, we solved systems with one solution. We solve systems with one solution. Also, systems with no solutions. And then there are systems with infinitely many solutions. Now, one solution we solve for, we did some examples, we should go on this. No solutions. If I give you a system, no solutions, that means they are parallel. And to be parallel, that means they have the same slope. So no solutions are parallel lines, they have the same slope. And infinitely many solutions means they're the same line. They're the same line. Let's take a look at a couple of examples of those. If I were to give you y equals 2x minus y minus 1 and y equals 2x plus 5. Well, if we look at this, they both have a slope of 2. So they have the same slope, but they have a different y-intercept, right? So this one is going to look something like this. The second guy is going to look something like this. They are parallel, but not the same. Therefore, there are no solutions because they never intersect. Likewise, if I were to give you 2x plus y equals 3 and 4x plus 2y equals 6. If you were to graph this, you will see that they are the same line. Go ahead and prove it to you. Let's go ahead, let's find the intercepts. Let's find the intercepts of 2x plus y equals 3. Actually, on a series. So we have a little more room to work. So when x is 0, y is 3. When y is 0, x is 3 halves. Now let's come down here. When x is 0, y is 3. When y is 0, x is 3 halves. So you see they are the exact same line, therefore they have infinitely many solutions. This wraps up section 4.1. If you have any questions, send me an email.